Let's try A first. Let's begin with sketching y equals 3 sine x. So let's open up the Desmos here, and let's punch in y equals 3 sine x. As you can see here, we're talking about radian mode. I'm going to change the window settings to step pi, or pi over 2. And as you can see that this here has a graph that's starting at 0, 0, it's going up to 3. The regular graph, y equals sine x, only goes to 1, and the minimum value is -1. So the number 3 we learned in transformations is 3 times taller, and it makes sense. So this is the a value. The a value affects the transformations. And so what we have is when we change it to 0.5, you can see that now the original sine graph, which is purple, is taller than this green graph, which is half as tall, 0.5 times as tall. If we change this to -2, as you can see that the transformation multiplying the function by -2 flips it. The green graph is flipped. What used to be pi over 2 comma 1 now becomes pi over 2 comma -2. It flips. So if we're to restrict this graph, we can use curly brace on Desmos. You could say that 0 is less than x is less than 2 pi. Pi means pi. And you can do the same with the transformed graph. 0 is less than x is less than 2 pi. So as you can see, here's the sketch. Normally the domain is all real numbers, but here you can see that because we're restricting the domain, it's only between 0 and 2 pi, and the range normally is between -1 and 1. But for this particular graph, -2, you can see the range is between -2 and +2. Now be careful, the amplitude, the word amplitude, this term is only interested in how big this wave is. The amplitude is the absolute value of the a value, so the amplitude is not going to be -2, it's going to be +2. If you just put a line between the x-axis and the maximum, you can see the height of this, the physical distance, is 2. So think of that distance as the amplitude, whether you're thinking of going up or even going down towards the minimum.